Remember that we chose to store our users and locations as Redis hashes. Hashes are a flat map of name-value pairs stored at a Redis key. So I have Redis Insight open here. Let's see what one looks like. So if I pick NCC users 574, that's user 574 in our system, we can see the hash that represents that user in Redis. So we have field names and values. The values can be strings or they can be numeric. Hashes support some atomic math operations on numeric values, and we'll look at that later in the course. So how do I use this or access this from IO-Redis in my Node.js application? Here I have the user routes file open. That's in source routes, user routes.js, and there's a route called /user/:user ID, which gets a user's hash and sends it back as a JSON object to the front end. So we basically just quickly validate that that parameter is actually an integer value and it's minimum 1 because our user IDs start at 1. And if so, great, we pull it out of the parameters. And then we use the redis.getKeyName convenience function that's going to namespace our key for us. So it'll take users and user ID and create the key ncc:/users:/user ID. So 574 in the example we're looking at. Now comes the retrieval step. So I use the hgetAll command or the hgetAll function in IO-Redis to get all of the name value pairs that are stored at that key. And IO-Redis will put them in an object for us, which is normally how we want to represent name value pairs. It makes it very easy to work with in JavaScript. Quick word about the hgetAll command. It's what's known as a big O of N command in Redis. So its performance is tied to the size of the hash. So the bigger the hash gets, the longer this is going to take because the more name value pairs it has to retrieve. So if you have thousands and thousands of name value pairs in your hash, I would suggest using the hscan command, which allows you to do this in an iterative way and build up the result over several command request responses to Redis, which puts less of a continuous load on the server. But we've got smaller hashes. We're okay to use hgetAll here, so we'll continue with that. So I've got all of those values back, and then I just have some code here. Sensitive field names is an array. It contains only the name of the password field at the moment, but it could contain others. And what this code here does is just deletes those fields that we don't want to send back to the front end, so we're not sending the password back. And simply respond with a JSON object and status 200 and pass it back our user detail. So if we look at how that works, I can start the API server here with npm run dev. That's up and running on AT81. I go to the browser, get a new window, and let's do localhost :8081/API/user/574. And what we can see here is that we retrieved all of the fields from the user's hash and deleted the password one. So that seems to be working nicely. Now, I said that when IO-Redis performs the hgetAll command here, it returns us an object. And it's doing a little bit of work for that, because if we look at what's happening in Redis underneath, so if we run this command in the Redis CLI, I do hgetAll ncc users 574, what you'll see is not something that looks like an object. It's a series of strings or an array of strings. And it is field name, so ID first, then field value, then field name, first name, then field value. So IO-Redis is taking this response from the Redis protocol that comes across the wire, turning it into an object for us and doing a little bit of convenience work for us there, which is handy. So you will get to use these features in the next coding exercise, where you'll use the hmget command. And what that does is, rather than getting all of the field names and values from a hash, it gets them selectively. So we'll pick some that you need to get to form up an API response, and you use hmget to do those.